right, Gio. Hopefully you did well on the Unit 6 test. If you still need to take that or retake that, please reach out to myself or Ms. Tesh or Ms. Dedeker, and we can get that squared away. Probably be a good idea to get that done before winter break here. We're going to continue on with our right triangle math, right? So if we go back to what we just took a test on, we have a right triangle. We have two sides of the right triangle. We can use the Pythagorean theorem, a squared plus b squared equals c squared, to find out the missing side length, given two side lengths already. Okay? Now, sorry about the noise, I had to something around here. Right? So now we're going to continue with right triangle math, but we're going to get setups where they don't give us. We're going to get a setup like this. They're going to give us an angle measure, a side measure, and have to find a side measure, right? You can't use Pythagorean theorem because 34 is the degree measure on the inside. It is not the side length. So this is another tool to help us find side lengths of a right triangle. All right, we call these relationships trigonometry or trigonometric ratios. It's just a ratio of two sides of a right triangle. All right, we have three main ratios that we talk about in geometry. They're the three main ratios. If you look on your scientific calculator, sine, cosine, tangent looks like sin, cos, and tan. These are our three ones that we have to worry about. Okay. All right. So here they are. It's a couple things we got to take a look at. So first off, the sine is the ratio of the opposite over the hypotenuse side. All right, so let's go back to last unit when we talked hypotenuse. Hypotenuse is always across from the 90-degree angle, always the largest of the three sides. That's always the hypotenuse. All right, now when we get to opposite and adjacent, that's always going to change, and it's always from our point of view. So if this is the Greek letter theta, usually used for angle measures, right, when we're talking angles. So whatever angle they give us is going to be our point of view. So we would label opposite of this angle. Go all the way across the triangle. That would be the opposite side. And then the adjacent side is the one that's next to it. Okay? So we have opposite, we have hypotenuse, and we have adjacent. That is what you need to be awesome at. That right there, just labeling the sides, right? Because everything else will fall into place if you can go through and label the sides correctly, all right? And that's what kind of today is about, is just labeling the sides and writing the ratios out. So the sine is the relationship and the ratio of the opposite side divided by the hypotenuse side, right? Cosine is the adjacent side over the hypotenuse side, and tangent is the opposite over adjacent. Now, if we take the first letter of each of these, there is an acronym that if you type it into Google, it will probably come up with sine, cosine, tangent stuff. Okay, so we got SOHCAHTOA is what we're going to call it, but it's just it's a little acronym and help us remember that the sine, opposite over hypotenuse. So it's got this trig ratio that we have right here. It has that in the letters so to help you remember, right? It's a little thing to help you remember without having to flip back through notes and stuff like that. Cosine, adjacent, hypotenuse. Tangent, T-O-A, TOA. So that's there to help you, all right? So all we're going to do today is we're going to spend time writing these relationships out. What is the fraction? Move on with our day, okay? So find the trig ratios for each function below relative to angle A. And then it says relative to angle B, okay? So forget about this relative to angle A. We want to find the sine of A, so we have to label our triangle according to A. Well, across from the 90, is always the hypotenuse. And then do opposite our angle. Be good at labeling the two, because then that means the one that's next to it, or the third one, is the one that you're not the greatest at labeling, right? So I would always do hypotenuse and either be good at opposite or adjacent, one or the other, okay? So what we would do then is we would look back at our notes, and the sine of A is equal to the opposite over hypotenuse, right? We scroll all the way back up here, opposite over hypotenuse. Well, now we just get to write the fraction out. The sine of A is equal to the opposite side, which is 6. Okay? Opposite side, 6, over the hypotenuse, which is 10. And then we would reduce our fraction down. Both of those are divisible by 2, which we would get 3 over 5. All right, now this is where it gets tricky. Now we want to do the sine of B. Since B is now the angle of reference, you need to switch these around. Okay? Now the angle of reference is going to move up to B, and opposite of B is now down there. So what ends up happening is opposite and adjacent switch around when you switch your focal point relative to the specific angle. We went from angle A to angle B. Okay, so now the sine of B is opposite 8 over hypotenuse 10, which reduces down to 4 over 5. Okay, so that's the gist of what we're doing, is just practicing writing these relationships out. All right, find the trig ratio, again, not relative to angle A. So we're going to do, here's angle A, so we're going to put our angle thing down there. Cosine, don't worry about that yet. Just get good at labeling. Hypotenuse, opposite, and adjacent. I'll switch that opposite, looks kind of ugly. Okay. Well, cosine above said it was the adjacent side over the hypotenuse. So then you look down here, the adjacent side is 16. That goes on the top of the fraction, and the hypotenuse is 20. So we would write 16 over 20. Both those numbers are divisible by 4, so we get 4/5. And then now the next one says cosine of B.
Here we go. Hi, Avery. How's it going? Good. Thumbs up. Nice. Can you unmute yourself for a second?
Sorry about the loudness in the background. My daughter decided she wanted to have dance class right now.
I'm filming a video for school.
Adjacent over hypotenuse. So it'd be 12 over 20, which is going to be divisible by 4, so it'd be 3 over 5. And the third one is tangent. Okay, again, so we go label opposite, hypotenuse, adjacent. Tangent of A, well, tangent is the opposite over adjacent. If you're not sure, scroll all the way back up. So then we would take the opposite side 15 and the adjacent side 20 and write them as our fraction. Reduce down, those are divisible by 5, so we get 3 over 5. Okay, and then now when we get to B, opposite is 20, adjacent is 15, which is equal to 5 over 3. All right, so now I just want you to pause the video, try these 3 ratios out, get the 3 for sine, get the 3, or sorry, for A, and then get the 3 for B. All right, so pause it. All right, so if this is A, that's opposite, hypotenuse, adjacent. Sine, so, right? So, opposite, hypotenuse. Opposite is 5, hypotenuse is 12. Cosine, ka, is adjacent over hypotenuse. Well, the adjacent 17, hypotenuse is 12. This is not even right. This triangle can't happen. This is these are backwards. This does not work out because that can't be the longest side. Anyway, I just noticed that now. We'll just stick with it because you guys already did it. But yeah, this triangle can't happen. And tangent of A is opposite. All right, so if we go tangent, opposite over adjacent. Opposite is 5 and adjacent 17. Okay, so now we do the same thing with B, except for our angle of reference goes up here. And we flip-flop opposite and adjacent. Now the sine of B is opposite over adjacent, which is 17 over 12. Cosine is adjacent over hypotenuse, which is 5 over 12. And tangent is opposite over adjacent, which is 17 over 5. So I want you guys to look at this and compare them to this row and tell me what you see. Hopefully you notice that the sine of A and cosine of B are the same, cosine of A and sine of B are the same, and the tangents flip around. So these are the relationships of the sides. This is what we call trig, right triangle trig. We're going to be using sine, cosine, tangent. So the biggest thing for right now is for you to be able to label the triangle and pick out sine, cosine, and